Hello, welcome to this short demonstration using OpenShift Pipelines to automate building your Java application in Open Liberty and deploying to Red Hat OpenShift container-based cloud. OpenShift Pipelines is Red Hat's continuous integration DevOps technology based on the open source upstream project called Tecton. Before I begin the demonstration, let's briefly highlight some of the core technologies of the DevOps scenario and where they fit into a modern DevOps for Java development with Liberty and Kubernetes. Traditionally, businesses had to manually build and compile applications and maintain large monolithic code bases. With a modern approach to application deployment that uses continuous integration and continuous delivery, you can more quickly build and test and deploy services. This modern approach lets you release applications and upgrades to your customers faster and respond to changing business demands in a more agile manner. Open Liberty and WebSphere Liberty is DevOps friendly and is extremely flexible as it relates to integration with modern DevOps technologies. As you will see, I will leverage several open source technologies to demonstrate a use case for continuous integration and continuous delivery of a Java-based Open Liberty application that is typical of a modern application development process. During the demonstration, open source technologies like Git, Maven, Builda, Docker, Tecton, Customize, and the Open Liberty operator are used to showcase a modern continuous integration and continuous delivery scenario of a Java-based application. So what is a pipeline and what does it have to do with continuous integration and continuous delivery, or CI/CD? A pipeline is a process that drives software development through a path of building, testing, and deploying code known as a continuous integration and continuous delivery model. By automating the process, the objective is to minimize human error and maintain a consistent process for how software is released. Tools that are included in the pipeline could include compiling code, unit tests, code analysis, security, and binary creation. For containerized deployments, this pipeline would also include packaging the code into a container image to be deployed across a hybrid cloud. CI/CD is the backbone of a DevOps methodology, bringing developers and IT operations team together to deploy software. As custom applications become key to how companies differentiate, the rate at which code can be released has become a competitive differentiator. Tecton is an open source project that provides a framework to create cloud-native CI/CD pipelines quickly. As a Kubernetes native framework, Tecton makes it easier to deploy across multiple cloud providers or hybrid environments. By leveraging the custom resource definitions in Kubernetes, Tecton uses Kubernetes control plane to run pipeline tasks. By using standard industry specifications, Tecton will work with existing CI/CD tools such as Jenkins, JenkinsX, Scaffold, Knative, and OpenShift. Now, OpenShift Pipelines is a Kubernetes native CI/CD solution based on Tecton. It builds on Tecton to provide the CI/CD experience through tight integration with OpenShift and Red Hat developer tools. OpenShift Pipelines is designed to run each step of the CI/CD pipeline in its own container, allowing for each step to scale independently to meet the demand of the pipeline. Tecton and OpenShift Pipelines contain the following Kubernetes custom resource definitions and can be described as follows. A task is a sequence of commands or steps that are run in a separate container in a pod. A pipeline is a collection of tasks that are executed in a defined order. Tecton resources include inputs such as a Git repo and outputs such as an image registry to a pipeline. Workspaces are parts of the file system that are made available to store its data required by the tasks. Workspaces are backed by Kubernetes storage volumes, secrets, or config maps and can be shared across tasks as needed. A task run is a runtime representation of an execution of a task, and a pipeline run is the runtime representation of an execution of a pipeline. This demonstration of using Open Liberty with OpenShift Pipelines contains the following activities. First, I create an application project in OpenShift. This project is where the pipeline will deploy the application in the Kubernetes cluster. Next, I create the pipeline resources in OpenShift. The resources are defined as YAML files and created via the OpenShift OC create command. Once the pipeline resources are created, I run the pipeline using the pipeline run resource. The pipeline will take several minutes to run as it clones the application Git repository, builds the application, creates the Docker image and pushes the image to the OpenShift internal image registry, and finally deploys the application to the specified project in the OpenShift cluster. Once the pipeline creates, I will verify the pipeline status and validate the application components are successfully deployed and running in an Open Liberty container on OpenShift. So let's get started. As you learned in the introduction, WebSphere Liberty is Kubernetes optimized and easy to integrate with continuous integration and continuous delivery pipelines. In the demonstration, we'll walk through the process to deploy the CustomerOrderServices application, which is a Liberty application running on Red Hat OpenShift. For the demonstration, a collection of assets are provided in a GitHub repository. The assets include the necessary YAML files that will make up the pipeline and its associated tasks. The first task is to clone the source code from GitHub and store it locally. Then we'll build the Docker image, and once the image is built, it'll be pushed to a local image repository in OpenShift. Then we'll deploy the containerized application to the Liberty runtime in OpenShift. Okay, to get started, let's clone the repository. In the terminal window, we'll clone the repository that's made available for this particular demonstration. With the repository cloned, let's navigate to the directory where we have the resources used for this demonstration. In the Tecton pipeline directory, take a look and we'll see a number of YAML files. And these YAML files represent the individual tasks and pipelines that we'll use for this demonstration. Later, as the pipeline is running, we'll explore the details of the individual tasks that you see here. The final task in our pipeline deploys the application to OpenShift into a specific namespace or project. So let's go ahead and create the project in OpenShift that we'll need for the deployment. The first thing we'll do is log into OpenShift, and then we create a new project named Dev for this particular demonstration. And the Dev namespace is where the CustomerOrderServices application will be deployed. With the Dev namespace created, let's just ensure that we're working in that namespace. So for this demonstration, the pipeline resources are defined in the YAML files as shown here. Now we could run the OC create command against each of these YAML files to individually create the resources for the pipeline and the tasks. But for the purposes of this demo, I've created a convenient script called deploy.sh that will create all the resources for us. As you can see, the script just runs the OC create command, referencing each of the YAML files as it creates the individual resources for the pipeline. So in order to create the resources in OpenShift, let's just run the deploy script. So now that the resources are created in OpenShift, let's just make sure that the tasks and the pipelines are available. With the OC get task command, we can see the individual tasks for doing the git clone and the build and the deploy have been created in OpenShift. We also have a pipeline that got created. So with the OC get pipelines command, we can see that the pipeline named tutorial-pipeline is created in OpenShift as well. So with the pipeline resources created, now we just need to run the pipeline. What we do is we execute the pipeline deploy-run YAML, which is the runtime representation of the pipeline. All right, so let's run the pipeline now. The pipeline will take several minutes to complete, and as the pipeline is running, I'll go ahead and navigate into the YAML files and explore the individual tasks and pipeline files. Using the OC create command and referencing the pipeline deploy run.yaml file, it will then run the pipeline. So the pipeline task is created, and once that's created, we can go and look at the status and see that the pipeline is actually running. We can do this via command line, or we can go to the OpenShift console and take a look at the pipelines. So within the OpenShift console, let's navigate to pipelines and go to our pipelines. Switching to the dev project is where our pipeline is dedicated to run, and we'll look at the pipeline runs, which is the pipeline that's running now. So as you can see, the pipeline details lays out the 3 tasks that I showed at the beginning of this demonstration, where it's going to first clone the repository, then build the image and push it to the repo, and then deploy it to OpenShift. So like I said, this is going to take a few minutes to run, and we'll come back to this in just a few minutes. Next, let's go back to the command line and just explore some of the YAML files for this pipeline. So I'll just open the files up in a local editor, and we can take a quick peek. So this is the pipeline run resource, which runs the pipeline. So I'm not going to go into a lot of details, but let me highlight a couple of things. One is that this pipeline run resource is referencing the pipeline here in which it's going to run, called tutorial_pipeline. And it's also creating the workspace backed by a volume where all the data for the tasks can be stored and shared amongst the tasks. And then there are some parameters that are used into the various pipeline and tasks. And so, for example, the repository URL is the URL in which we're going to clone the repository from and make local. So the first task in the pipeline would clone this repository. We have a target namespace where the application would be deployed, and that's called the dev. So you have a variable for the dev target. And then a variable for the builder image that will get used for running the builds, the push to the image to the repository. So that's a quick look at the pipeline run. Let's look at the actual pipeline itself. And this is the pipeline deploy. So this is the tutorial pipeline that's getting executed. Now the pipeline just basically orchestrates the order in which the tasks are going to run. At the beginning of this, we'll see that there's some parameters set up for the variable substitution into the individual tasks that we mentioned earlier. And then we start to list the tasks. And there's a task called get clone, which is basically going to clone the repository that's referenced in the URL. Then there's a task called build-push, which is going to run the build command and build the image. And it's going to push it to the internal registry referenced in this registry value here. And then finally, there's a task to deploy to the cluster. So the deploy to cluster task. So within the pipeline YAML, the tasks are ordered based on the run after parameter. So first, the get clone runs, then the build a task runs after the get clone, and then the deploy task gets run after the build push task. All right, let's take a look at a task. So this is the get clone task. This is a pretty comprehensive task, right? So there's a lot of variables that get substituted for the various ways that you can clone and commit from the GitHub repo. But at the core of this particular task is that it has a step to clone the repository, and it runs a shell script to be able to clone the repository based on the parameters that are put in, and check out the appropriate code on the system for the builds. So I don't want to go into a lot of detail there. It's just a bunch of code. Then there is the next task called the build and the push, which is in the build YAML. And this build task has 2 steps. The first step is to do the build, which then he's basically running the build command, which builds the Docker image, right? And then after the Docker image is built with the application, then it runs the push step that pushes the image to the internal registry in OpenShift. So at a high level view, that's the build task. The final task is the deploy. So the OC deploy YAML. This is the task that's actually deploying the application to OpenShift. So in this case, we have a step that's deploy Open Liberty, and we're telling it which image to deploy, and then we're running a script that's using some OC commands and a tool called Customize to be able to overlay the default configuration into the various namespaces, and then apply the YAML based on the Liberty operator into the target namespace, which is dev in this case. And then at the end, we get the route for the application that's deployed into OpenShift. Okay, so that's the very high level view of the tasks and the pipelines that we're using in this demonstration. So let's go back to the pipeline, and at this point we can see that our pipeline is actually completed. the get clone has completed and passed, the build push is completed and passed, and the deploy to OpenShift has completed and passed. So from here, we could take a look at the individual tasks and the logs, and to see what's going on. If there happen to be any errors, you could take a look and see what's going on. The last task, the deploy to cluster, I wanted to just take a look at the logs in here, because in our YAML, the last thing we did is went and got the route and printed the route information into the log. So this is the route to the application as it's running in OpenShift. So let me copy that and see if we can access the application running in OpenShift using the route. So as you can see, the application is actually running in OpenShift. It does have some security enabled, so I have to be able to log in. So just log into the application, and then we can see that the application has then showed the shop for the electronic and movie depot, in which case we're in the movies category by default. You can see a list of movies that are available that we could add to the shopping cart. For example, we could purchase, right? So that's the application. But let's go back to OpenShift and take a peek at the resources that got created as the application was deployed. So for that, we can go into perhaps workloads and take a look at the deployments. And here we have the cause application, which is the customer order service application. And it has one pod that's running, right? And that pod is up and it's running. The next thing we do is look to see the service and the route. So the service information, which is the fronting of the application, and you see the service is created, and then as part of the Open Liberty operator, it also created a route that references that particular service called COS, right? And this is the route that we accessed a moment ago with the context route for the application. So at this point, the OpenShift pipeline has deployed our application using the pipeline resources and the Open Liberty operator. And our application is up and running in the OpenShift cluster. In summary, what we saw is that WebSphere Liberty is Kubernetes optimized and easy to integrate into an agile deployment. So in this demo, we showed the CI/CD pipeline for deploying my containerized application running in Liberty into the OpenShift environment. And we learned how to create and run the Tecton resources involved in the pipeline deployment, including the tasks and the pipelines and the pipeline run. Thank you, and this concludes this demonstration.